Some of very amazing applications which I today intend to discuss. And then we shall spend time learning about unsupervised learning. So this is what we did last time. We discussed joint probability distribution function, and then we briefly discuss generative AI and GANs. We are going to spend more time on these. Then I talked about the stochastic processes, that how we can use stochastic processes in planning and prediction. Learned about information theory, and this is where we ended, like how to design a decision tree, and gave you an example of a PhD work of one of my students. Today I intend to talk about some of very amazing applications of AI. So continue discussing decision tree classifier and code generation. And today I also want to give you a very quick preview of Python, because the code we are generating is in Python. So I want everybody at least able to read through the code so that you know what the code is doing. So though I don't expect anybody to code in Python, but just a basic understanding perhaps is important. So going to do some clustering and applications, k-means, hierarchical, DBSCAN, and those of you who already have background in machine learning, you must have already learned these things. But then I have used it for a PhD research of number of my students, so I'll be discussing that what we did with all these techniques, and especially for PhD research. So like every week, this week I want to dedicate it to this sound. So let's see, what sound is this? If I can. I hope that will play. So anybody has any guess which sound is this? Okay. So many researchers are just spending all their life on this sound, and we'll find out what they are up to. Okay, so this is the sound of whales. Okay. And people are trying to learn that they believe that they talk to each other, whales, and they are using a language. It has semantic, it has meanings. And using AI, they are trying to understand. They're just trying to understand their dialect there. So an amazing research. So the first of in the list of the amazing application is this Dominica sperm whale project, and where they are trying to understand the communication in whales. And so it's a lot of detail about the project, where you can click a link and you can find more details. And how they are actually collecting all these sounds by multiple means, that they have drones, and they have underwater drones as well, which looks like a whale, and it goes and swim with the whale. And then they have something on the whale body as well. So they are collecting all this data from different sources. And then they have figured out that the whales, they have two type of sound. One is echolocation, where they locate themselves the way they are. So their sound is a very sharp, and they have the loudest sound of a living creature on earth, whales. So they are basically localizing themselves the way they are. So this is just one type of sound. And they say it is produced with interclick interval. As we have seen, it's like more code. So it's an interclick interval of 0.4 second. And they have coda clicks, where they actually talk to each other. So the coda clicks are arranged in sequences called codas. and codas are characterized by the different number of constituent clicks. That how many clicks are there, 3 or 4 or 10, and so they are clicks, and then there is a interval between the clicks. So that's how they are classifying codas. And it is produced in multi-party exchanges. So that's why they believe that they're actually talking. So there are multiple whales that they are actually, once they are talking to each other, and it lasts from 10 seconds to over half an hour. So once they're talking, so half an hour. Each click, it is a sequence of equally spaced pulses with interpulse interval of an order of 3 to 4 milliseconds in adult female. So these are the echo collocations, as you can see here. Here. So this is where they have like inter-click difference, and they just click, 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 click. And these are the codas where they have different number of these, and then there is an interval. Okay. So there is this one, that there's a different number, and that's what they are just collecting. And they are collecting, and they are trying to make it into a large language model. Okay, so that's interesting part. And they say that the current project has only, which is a small dot. This is the current project where they have collected a lot of the sounds, and where ChatGPT-3 has only part of the ChatGPT-3 is shown. So they are funded for this, that they are going to make a large language model of this size. And as we can see, that's like quite comparable with ChatGPT-2. So that's what they are going to do, that they are going to have like more of these, collecting a lot of the sounds. And then what they are intend to do is, so these are the raw audio, these are the click detection, and this is important, source separation, as we do, especially in ELINT system, electronic intelligence system, once there are multiple radars working. So a source separation is a very interesting problem where we intend to find out how many actually transmitters are there. And so there is a way that you can actually figure out. So they're doing source separation, that sound of every whale is, they are getting those separated. And then they are just trying to not only that it is the sound, but they are also collecting several other information like videos. They are making videos when they're producing this sound. The environment, it may have some effect, temperature, current, prey, if they have any, their behavior, that are they in panic or they're happy, or and the depth. And so this is all what they are doing. And then is this is where they are collecting. This is one of the projects where they have collected so many codas and clicks and approximate time of the calls. And so these are the audio files, which part of their call carry information. They are trying to figure this out. What are the protocols of information exchange? What is the information? Learn the meaning, the calls, synthesize call, and important is communicated back to the whales. So that's how they're doing the validation. So it is, can they actually make an encoder, and can they actually make a decoder? Okay, so both sides. Like encoder is, can they also produce and start communicating with the whales? And to see, to validate that they have understood it right. If somebody is calling someone, so they intend to produce this. So the validation through replay of that sound to basically validate whether they've understood it right or not. So it's about the encoding of the sound. They got to learn about the encoding, that how encoding is done, and about the decoding. And apparently it's not that a difficult problem. Okay, especially the way they are communicating. So they are figuring out the.
So in fact, all animals and birds, they have some communication.
Yes,
so
precisely. Why whales?
Why we prefer to
whales? Yeah. I think they think that whales are the most intelligent creature. Number one, and number two is it is easier to basically encode and decode and classify, and especially the way they are communicating clicks. So clicks are like Morse code. So Morse code are easy to handle and easy to produce, and perhaps this is one of the reasons that so inferring meaning, and then discourse of social communication, and also playback based validation. So that's important, and they have been working on this, and they got funding also for the project. So this is very interesting. There is an article which you can click and read, and which says that as the birth was communicated, they announced the birth of a new baby. So, and then always they come and just congratulate. So that's they have captured through the cameras, and that's what they are trying to figure out, that how they basically announce the birth, and then they see all the whales coming and. So this is one interesting application, and this is what like people are trying to do. And you are right, if they could actually able to find the that how the whales communicate with each other, they may then extend it to other birds and animals, and that will be very, very amazing. That if you could actually able to figure out that what they are talking, and if there's actually a language, semantic, grammar in their language, and which they believe it is because of the way they have collected data, and it is different, and based on their behavior, based on the temperature, based on the situation. So the second interesting is another project, which is they are trying to capture the brain activity, that what your brain is thinking, right? And this is end-to-end deep image reconstruction from human brain activity. This is the paper, and you can click here, and actually you can get the actual paper as well. And what they are doing, they are just using an fMRI, which basically measures the small changes in blood flow that occurs within the brain activity. So there's whenever we see something, so there is a change in the blood activity. So they are capturing that change through fMRI. And then they have this network, GAN, where they basically first they train the GAN. So they make some subjects, some people to see something, and they just think it in their mind, and then they capture the fMRI, and they train the network. Okay, so they are just training the network that so once you have seen an image, and using that image and the fMRI, they are training a generator to generate it back from the fMRI. And remember, in GAN, you are actually generating images out of noise. Okay? If you can generate something out of noise, then definitely you can generate something through fMRI as well. And provided each fMRI associates with an image. Okay, if you trained it, showing it many images, and you have a generator and a discriminator, and you just train this network, and then you just you need to have a generator to basically see whether you can regenerate what a person is thinking. So that's what they have done, and these are the results. Okay, so these are like the three people, and here are the stimulus that they're showing this, they're showing this, an airplane, okay, this. And then this is subject number 1, subject number 2, and subject number 3. And this is what he could actually, the generator could able to just convert the fMRI into these images. And these are like kind of a good representation, not exact, but good representation of what a person is actually seeing. And then they extended it to simple images like a plus sign, a multiplier, an adder, and then generating all of this. So here is, as you can see, it's like kind of a plus sign. It is kind of a multiplication sign, addition sign, and especially you can classify it into one of these. One is that generating an image. The other one is classifying it into one of the images that you have in your vocabulary. So this is also the same, and here they are just having number of training samples, like showing many training samples, and then just saying 120 samples, 300 samples, and 6,000 samples. So this is what you can actually generate once you have these many samples. So this is the second interesting thing, and an application of GAN as well. The third interesting is where they are just trying to generate an image out of Wi-Fi signals, again using a GAN. So once you have multiple Wi-Fi transmitters, and they are just reflecting with human bodies, and then again training a GAN to create a picture of what is happening in the room. So this is again, they have trained this GAN, and so this is happening in China. I think that was one in Japan. radio waves and generative adversarial network. And here is like you have RF extractor. These are the receivers. So RF extractors bringing them, and this is the GAN, where you have a GAN, and GAN is actually generating images of the environment because it is trained to generate, and all it has to figure out is somebody is walking and somebody is sitting and somebody is moving in the lab. So, and then they are also doing human pose. This is another paper using radio signals. Then we already know about the fourth interesting is the large language models. And we know about ChatGPT, we have been extensively using this.
What is the application of the previous?
Previous application is maybe for from like some intelligence perspective, you can find out if there is somebody in that vicinity where you don't want people and what they are doing, for example. So because everywhere there is Wi-Fi, you don't have to put extra sensors. So you just train a GAN, and now you are sure that there is nobody in that area. There are people who are and what they are doing. And so I think there are many applications because now the Wi-Fi is everywhere. So you are using Wi-Fi as a sensor to gain more information about the environment. So we already know about the LLMs and large language model because we are using it. It's also an amazing application, and it has like now billions of users, and number of people who visits are in 1.6 billion. These are these eight the most interesting language model. We are using this GPT 3.4. But then there is GPT-4 as well. Apparently, you have to pay a little for this. Then there's a Bard, which can explain your code to you line by line. And if you have a source code written, millions of lines of code, it can just explain what the source code is doing. Llama, we are doing some work in, and maybe at some point I'll show you the work we are doing in CASE, AI Lab, Dr. Yasir, and with some students. He's working on this large language model, Llama, which is an open source, then anybody can download and locally use it. You don't need to be connected with the internet. So that's the interesting part of Llama. And Falcon, as I told you, it is from UAE, and they have actually trained this model. And then is Cohere, PLM2, and Cloud V1. And there are many, which every day people are coming out newer and newer models. But this is also very interesting. This is from application number 5, which I want to discuss. And it is from Washington Post. It says they thought loved ones were calling for help. It was an AI scam. So also AI scam, like this is the grandmother, and her grandchild called, and he said he's in jail. So he asked her to send him some money, and she actually sent because she believed that it was actually her grandson. It was so AI is also used, and that's why people are really worried about that. They can just make on a telephone call as if you are actually talking to your loved ones, whereas he was not there. So as he says, we were convinced that we were talking to Brandon, the name of their grandson, and you can find this article also on the internet. So this brings me to the topic we were discussing. Let us just quickly complete the decision trees classification. And remember, we said in the decision tree classification, you get a table. So this table is important. Like you don't have any decision tree as such, and that's the strength of a decision tree. That some of these you may just be collecting without a person knowing as well. Okay, just without a person knowing. And I was thinking its application is so many places where you are taking decision. And in surveys, you can ask a person, for example, somebody going and buying a car or seeing a doctor, or anything where you have multiple options, and you can ask people through a survey that how are you feeling about the service. And usually people ask like, was the wait enough, or you have to wait for so long? And some people, you ask questions to find out whether your customers are happy or not, and also to find out churn, like once the customers are moving from your business to another business, and they have a decision making process, and people want to know that why they are churning, why they are leaving your business and just going somewhere else. And decision trees can really help that. If somehow you can figure out, ask questions, and then extract a decision tree that, so what is the most important thing that people have once they come to you, and once they are not coming to you, what else can you do to basically, so these are all the things that you can actually make applications. And rest of everything is very simple. Like, it's about that how creative an application you think, and then if you're going to use decision tree, then it is very straightforward, and you even don't have to do it yourself. Just ask the chat GPT to make a decision tree for you. And remember, we talked about the information gain, that the very first decision, the very first aspect of the decision tree has to be the one which basically gives you maximum information gain. And how you calculate information gain, we said all the parameters you make separate tables. So you have one big table. So you have one big table. So for now you make a table for weather, temperature and wind. So 3 tables. So you separate them into 3. And then within weather, you again say sunny, rainy, and overcast. So again, from a subtable, you make a subtables. Okay. So again, perhaps you don't have to do this. This is a chat GPT. Leave it to the chat GPT. Just give chat GPT a table and tell chat GPT to have information gain as a measure, create a decision tree. So there are other measures as well, but I think information gain is a good measure. And then I'll show you some of the code I have generated by just asking that do this, do this, do this. And so this is what we learned last time. That you have first the information gain of this, that what is the probability of somebody going to play and not play. If it is 50-50, then you have the maximum entropy, which will be 1. But as it is 70-30, and so it's 0.8812. So maximum for 2 is 1. So it's a 2 raised to the power 1. So if there are 4 equally likely events, it is 2 raised to the power 2, maximum is 2. If there are 8 equally likely events, it is 2 raised to the power 3. So it's simple. It's a log base 2 of the total possibilities. So you can find out this is the maximum uncertainty in a sample space if there are multiple options. So it depends upon how many options are there and how the probability is distributed across those options. So if it is equally distributed, you have the worst case of uncertainty where you don't know what is going to happen. But in this case, as we can see, there is more probability that he's going to play. So it is already less than 1. So you have some information gain already, that 70% of the time somebody is going to play. So you have some information gain. Okay? So this is the information gain line. If you say he always goes and play, so uncertainty is 0. It means that you have like 0 information gain or information, so to say, because no matter what, you are going to have only one outcome. So this is what we did. Like for weather, we make a subtable, weather sunny, a subtable. Okay, and from this weather sunny, you see what is the probability that he goes and play, and what is, so it's like 0.5 is the probability that is the weather is going to be sunny out of the 3 options, and he's going to play and he's going to not play. Similarly, you have rainy, again you find out this, again you have overcast, you can find out this, and then you have the information gain. This is how you calculate. If you have only that subtable, so you calculate entropy. If you have only these, if the decision is only based on weather, you have this, and you basically find out based on the weather what is the entropy. Okay, and then based on the, so you say here is the information gain. So out of 0.88, you subtract, you get this number. So this is the number. Okay, so this is the number. So then you do the same for temperature, and we already did this, and then you do this for and find out the information gain. Then you do it for wind, you find the information gain, and then you have this table, and here you decide that the first branch you are going to take is for the temperature. Again, if you change the table, these options will change. Okay, because all based on the data that you have collected. If the data changes, these options will change. There will be another decision tree that you have to create. And this perhaps is an optimal, but it's not just one solution. There may be many other solutions which will give you the same answer. So we said, okay, this is the decision tree. That first decision is about temperature, then is about uh, the humidity, and the third one is about the windy or wind situation is what. So what I did, I asked ChatGPT to generate. This is the exact prompt which I gave to ChatGPT. Generate Python code that generates a decision tree based on a table with different attributes and labels. Right? And you can actually provide it with a table as well. That for this table, or can ask that I'll input you a table and generate a decision tree for me. Okay, create tree based on information gain. Okay, so I asked it, so it generated. And once it generated, it was based on random data. So random data does not make any sense because it's just random. But it generated a tree and which was based on the random data. So I checked, it was always giving a lot of error once it was testing the tree. Okay, so can somehow we plot the decision tree as well? I wanted it to plot. This is my second prompt. Then I said, plot a decision tree for me. So it plotted the decision. It was like big decision tree because there were 100 entries in the code, in the table. So then I said, no, use some benchmark data. If you already have some benchmark data, or you can say, I'll give you a benchmark data. I said, use some benchmark data to build a decision tree and check accuracy. Okay, because the accuracy was really bad for the random data. And then I said, can we plot this tree as well? So I said, I wanted to see the decision tree. So this is what happened. And as you can see, and this is where now I want you to actually read the code as well a little. It's like a story, honestly. It's like importing something. It is from sklearn. It is importing decision tree classifier. There is another model selection, training test split. So it is all the things which people have already developed for you. That's why Python is such an amazing tool that a lot has people already developed. So all you have to figure, the ChatGPT is figuring out what all you need to actually develop this code. And then it is some random seed, but then he's generating 100 samples, a table of 100 entries. Okay, 100 entries. Now I can understand there are 100 entries. Okay, this is fine. 100 entries, like in our table, we have multiple entries, whether it is sunny or hot and this. Okay, so in this table, he has 100 entries and 2 features. Okay, maybe you can call it a weather or humidity or anything. For blood pressure, maybe your weight and height. So it has 2 features. So it has just created random data. And then randomly it has created a label as well. So this is where the problem is actually. So he said, okay, here is the label that you are diabetic or you are not diabetic is just randomly generated. Okay, somewhere I'll put 0, say that it will put 1, 0, 1, 0, 1. I'll just put that and make a table. So this is the table which should actually come from an application. Okay, so he has randomly generated, and this is where he's splitting the data into 2 parts. One is the training part and the other one is the test part. So it is a 20-80 split. So 80 entries is saying, okay, let me just create a decision tree, and 20 entries then the code is going to check whether how good a decision tree it has created. Okay, and based on that, and so here is the decision tree classifier. It says use entropy as a criteria. Okay, and this is again a seed which it is giving, and here train the decision tree on the training data. This is how it trains this function, make prediction on the test, and now it is giving the test to check the accuracy, and based on what is predicted and what actually was there, it will give you the accuracy. So it's just you can read the whole code as a story, as just that these are the steps what we have learned. It has actually done the same steps. So just it will give you comfort and also more understanding of how the things are working in ChatGPT. So this is what it has created, and at random data accuracy was like first 0. Then I said no, reduce the entries to 10. It increased the accuracy by 0.25, but very bad accuracy. Actually, every answer was wrong once it was testing, and perhaps it is because of the randomness. So accuracy was 0. Then I said no, load something, a benchmark data. So its favorite is iris. Okay, it loaded iris and rest the data is iris. Only X, Y are coming from now iris. So the data is coming from iris and target. There are 3 different classes of iris. Rest of the code is same. As you can see, the same split of data. There are 150 entries in the table. So split is the same. Decision tree classifier is the same. It is creating a decision tree is the same. And then predicting and testing the accuracy is the same. And then it is testing what it has predicted and what is already there. So randomly, it separates 20 of the entries from the table to validate whether the decision tree is correctly constructed or not. Okay, and whether even decision tree is a good classifier or not. This is also another way of looking at it. So this is the decision tree which was giving me accuracy of 1. And as you can see, every leaf node is entropy 0, entropy 0, entropy 0, entropy 0. Means it could actually make a decision tree where there is no confusion. So this branch, at least in the training data, will get you the exact answer. So it has actually created a decision tree where all the leaf nodes, they have entropy 0, means only one type of class is there out once you go through this if-else statements. That if length of this is this much and width is this much, you go here, otherwise you go here. If length of this is this much, height is this much, you go this way, you go this way, okay? So means that if you have any table, you can go through the same set of if-else statements and get to, and at least the decision tree will tell you whether it has actually able to do this or not. And then once you test it, and we know that iris data has 3 different types: vascular, setosa, and so these are the 3 different classes. So every entry is labeled with 1 class, and there are 4 numeric values and 3 labels, 3 types of labels. And this is an example of example entry in a table. So this is what is important, that once you are creating a decision tree, you got to first create a table for yourself where you have features. As I mentioned, if it is diabetic and you want to see somebody is diabetic or not, and you may want to see his age, say this is his age, weight, height, okay, and maybe his blood pressure and and other things. And then you label it whether this person is not diabetic, not diabetic, diabetic, not diabetic, diabetic. This is the table we are talking about. So all the features, and they may be many, you list them here in the table, and here are the subject: patient 1, patient 2, person 1, person 2, person 3, person 4. And without somebody taking a diabetic test, and you are just, let's say, trying to figure out whether he's diabetic or not, and you have multiple features which may or may not just help you to identify that he may be diabetic. So you can create a decision tree and you can just give this table. And as I also mentioned, that for almost any decision you take, okay, and especially people who are doing business, they must know the decision tree of the customer, what customer thinks. When somebody comes and buys something, may it be a piece of land which they are buying, a plot, a house, an apartment. So everybody has a decision tree, and there may be multiple people may have different, but that will come here, that a person is just investing or is buying it for himself, or this is his income, this is his saving, this is this, this is that. And then you say, I can figure out whether he will buy this or not, or whether he's just, a decision tree would help you to get into the minds of people and find out how they make decision. And that's important. So this is like some of the entries of this label, some of the entries of this. Humanly, it is impossible for you from out of these numbers, you create a tree. Okay, it's almost impossible. But systematically, it is just making one feature, finding on information gain, then another feature, then another feature, then another feature. There are 4 features actually. And then out of those 4 features, it is just creating those if-else statements, and which are here. So I'll show you those. Okay. And then if you must have seen that there is everything, somebody has done it for you. So that's why ChatGPT so conveniently can just generate almost anything, because it is so compact and so easy to use utilities which people have already developed. Okay? everything that has to be done for decision tree has already been developed. One is that you go and learn this sklearn library and find out yourself. The other one is just ask ChatGPT to give you step by step, just lay down everything and you just go through it and you say, yeah, it seems okay. And if you have to change something, you can just go and change it as well. As I was just playing with some of the entries. And so it's a free software machine learning library for, I think they have been developing it from 2001. Okay? Yeah, so that's the Python programming language. It has various classification, regression, clustering algorithm. Okay. So, so this is, I think we need to mute this mic. So this is where you can actually go and find more about this. So usually if a reference is important, I'll always put the reference in my presentation. So you can click and go to the actual website where they talks about the history, how this has been created, what all you can do with this utility, and then they have several examples as well. So that basically prompted me to give you a very quick overview of Python. As I already mentioned, I don't expect you to code in Python, but at least you should be able to read the code. So very quick, the good thing about Python, that's why even children, like kids from class 8, 9, 10, they are also learning it very quick. So what you do is, but you can just set variables without worrying about whether something is integer or a float or a complex or a string. You can just, and a bunch of them together, you can just write them down. So no explicit declaration, dynamic typing, heterogeneous items you can put in a list. C++, I have like even coded in assembly language. So I have coded in assembly language, and I'll show you like some of the code which I have in assembly language. Okay, so especially for digital signal processors where you need to worry about that, what you need to bring in the register, what is the register file, and how you basically multiply them together, and then you store it back in which register, and scheduling. So that level of details that you have to know about the architecture. And even the C++ is very cumbersome. I have like, this is what we used to teach kids that learn C++. And it was very first course I taught in case was actually learn C programming. So I think video is also available. But that is very difficult to learn programming. The Python is just so simple to, it is free, it is object oriented, it's many built-in methods, many libraries, toolkits, environments, and it is even you do not need to compile it. It just runs, and once it finds an error, I'll tell you here is the error. So these are all the great work people have done for you. So Pandas is the data analytic library, Matplotlib is data visualization, TensorFlow is machine learning, Keras is deep learning. So, and ChatGPT knows all of this, okay? So what to use, when to use, I'll just go and I'll import that utility, that function, that module, SQL module, Scrappy for web crawling. So all these are already there. These are the mathematical function, NumPy. And then, especially for AI and machine learning, the TensorFlow we are now using for the decision tree and clustering. We shall be using this sklearn library, and then there are other as well. And then there are even for generative AI, the people are coming up with more libraries like OpenAI Python and Best Python tools. And so they are even for GAN and other stuff as well, Open LLM. And so people are continuously adding more and more wealth into this pile of code that they have written. So dynamic typing, indentation is important, that you got to make sure your indent is right. Once you write a for loop, you got to indent so that you can write functions. Operator overloading, like you can add as add, but also it can append two strings together. And then the print is very flexible and very concise code, very little code, it's doing a lot. So these are like primitive, it's called atomic data types, where you can just have an integer or a float or a character or a boolean or a complex just by assigning something to a variable. And then you can have, so these are like kind of 5 different types, which are the collection data types, which are the molecules, like more than a character or an integer or a float. So you may have a string. So you can, like string, usually you write here. So this is a string. Then you can have a list. List uses this bracket, the square bracket. Okay, so there are items, item 1, 2, 3. Usually index starts from 0 as in C programming, and MATLAB index starts from 1. So index is 0, index is 1, index is 2, index is 3. And then x tuple is another thing, but the brackets are important. Once you put this bracket, it means it is an x tuple where you cannot change the value once you assign it. Set is where you use these brackets, curly brackets. So a set is, if you have these brackets, you can use all set operations like union, intersection. And this is dictionary. So usually you have dictionary, which is key value pair. We say you have a key and a value pair. Usually in databases, we have a key value pair. So you have 1 is this, 2 is this, your name is this, your age is this, your job is this, your salary is this. So there's a key and a value, key and a value. So if you key and a value, you make a dictionary. Okay, and so you can have all these things, and so you can just define a list like this, an array of numbers, for example. And this is index is important because through index you can, and then you can have a mix. If in C you are going to do this, you got to make a data structure, and you got to have, first you have to define type, def, structure, and then you have this element is boolean, this element is integer, this element is a string, this element is an array of numbers, and then handling that structure is so difficult. It is so convenient that you can just put anything you like and put these square brackets, and this becomes your variable. And so you can say, if you want to access the first element, you say z0, it'll give you the first element, which is 3. Okay? So it's very simple, and it also does an index 0, 1, 2, 3, and another index -1, -2, -3, -4. So you can also say index -1 means 3. So negative indexing is also, it relates to the positive indexing. Then you can have from 0 to 2, excluding 2. So it's index 0, index 1, it'll give you 2 numbers, 3 and 7. So this is possible. So this is from start to 3, not including 3. So it'll give you 0, 1, and 2. It'll give you 3 numbers. So you can replace a number with a string. So this is really amazing that what all you can do. So you say, okay, I want to replace this 7 with a string. So you can do that. So that is the type of flexibility you have in Python. And here I have just, I myself just copied it and put it in the simulator. And so you can just actually run it, some of these commands. So here is a string, and you say print index 4. So it will find first 4 it hits, and it will print you the index. So a lot of those utilities have been built into the Python. Like you say append 3, so it will just append 3 end of the list. And you say remove 2, it'll just remove 2. The first 2 it finds in the list. So again, if you're actually doing program, it'll take you forever to actually append a linked list because you have to connect it again. And so, but here you can just pop 1, okay? And so here is so pop mean it'll just pop what is at index 1. So it is 0, 1. So it'll take this out. So it'll pop this, and then you are left with the rest of the Z. Extend with this, so I'll put another list. So you can concatenate to list, and so you can just go over, all of this. Insert this 1 and 2 at before 4, 0, 1, 2, 3, and before 4, I'll just insert a list. So, and this is tuples. Tuples you can define with this bracket or without a bracket. So the 2 ways. So this is how you can index, both are equivalent, and contain, and you can have a tuple with true, Boston, 1, 2, 5, and you can print like you were printing the list. So index 0 means it'll just print 3. Similarly, index -1 will print 2. From 0 to 2 is 0 and 1. It is going to print 3 and 7. So everything which you did almost there was, you can do it here. And here is something important about mutability. Mutability is like you can override on something where you cannot override. It's like a constant in C programming. So each object is assigned an address. So it's like pointer. So you can have an ID. ID is the address of that particular list where it is stored. It will give you the first address. And so the address remains the same. Immutability, all primitive types, strings and tuples, these are immutable, means that you cannot change their value, okay? And whereas lists, sets and dictionaries, you can change, you can amend, you can update these things. So here is where you have the ID. So this is what I printed. Like you have a list 3 to 1, and once you say ID, it'll give you the address. This is the address where in memory this thing is stored, and you append 4 in the list, and the address will remain the same. Okay, so it is not creating another list. So it's just append at the end of the list. So that's what it does. So you can create, let's say here you have again added something, append something, but it has not changed the address. Address remains the same. So this is called the mutability, that you can overwrite. And similarly, in other programming language, you have for loop, for, word, in. It's just amazing that how concise you can be. So from this, it is going to just take a word by word. So it'll take today and flip today, and then it'll take is, it will flip is, and then it'll take Sunday, it'll flip and Sunday. This is what the code is doing. But the for loops are there, and you got to be careful about the intending, that you got to put the tab intent there. So here is also something, if target not in E, okay, so for I, and this is the loop, enumerate collection. This is the collection where you have the string, a list, a set, and a tuple, and you are figuring out whether E is there or not, whether in this list an E is there or not. So not in E, so it says sorry, K, if K is here or not. So this is the target is K. So if the target is here or not, so it's a K not found, K not found, K not found, K not found. So it has if else statement, only if. So this is, if this is true, it will execute this. And if else, if this is not true, it will come and do the else as we do. But if this is true, it will only execute if and will skip else. So this is an if else statement. As we know, if else is you check something. So if it is true, so it is true and it is false. So you do one of these. So I just printed this. So it's just go and execute this. Similarly, while loop is in all programming. So we have while that keep looping here until this is false. It says x is less than 100, and you start with x is equal to 1 and check whether it is divisible by 29 or not. X remainder 29, and then you go increment. And so it has like next divisible by 18 is I think this is 29, 58, and 87. These are divisible. So similarly, the functions, as we write in every programming language, the function is, here is name of the function. This is how you define a function. Here are the parameters that you give, and this is the return that the function is returning. This is another function, just print, and you are sending A and B. I'll just print the first and the second. So here you call a function A and B, and average A, B is Z, and then you can print. So you can have a function by using def, okay? Always return a value, returns none if no explicit return statement. If there is no return, then it will not return, otherwise it always returns something. Parameter passes and returns as tuple. So this is, I'll just very quickly keep going over Python just for you to read through the code. Otherwise, uh, I have no other intention of doing this. Now let's come to the supervised learning. And as this is the first, in the first um, lecture, we talked about AI, then we said it is the subset of AI is machine learning, and a subset of machine learning is deep learning. And within deep learning, we have generative AI and the other stuff. So I will not go through the definition that how this is we have defined AI, but machine learning is that without explicitly programming, you want computer to learn, the ability to learn without actually programming it for a specific use case. So two types we know, unsupervised and supervised. This unsupervised lead to generative AI. And I always feel more excited about unsupervised learning because here you don't need a labeled data. So labeled data means, and this is what we don't have in Pakistan most of the time. That's the problem, that you don't have labeled data, where labeled data means that somebody intelligent and expert has actually labeled it, and you have about a data where somebody who has viewed the X-ray, for example, and he says it is because of, and he has actually labeled all the pixels in the X-ray and has said because of this X-ray shows bronchitis, for example. You don't find this data in Pakistan, okay? So people have not spent time actually labeling all of this, all the knowledge they have, because it requires, it's very painstaking for somebody to label for AI to learn. Not just labeling, yeah, this patient has bronchitis, that is fine. But why he's saying that this patient has bronchitis means a lot. Means like somebody has to sit, actually take a digital X-ray, identify that why he's saying, what, is it the region or the pixels, and because of a part of the lungs. And he said, because of this, I say this person has this much. And in Pakistan, we hardly have any of this data where people have spent time in actually labeling a data. There where we could do supervised learning. So all the data we have almost is coming from some benchmark databases where people have funded, and then people have spent time in actually, because obviously it takes a lot of money to label a data set. So for our population, we hardly have any labeled data set. That's the, even the X-rays we don't have any digital X-ray, and nobody has actually pointed out that why it is saying that. So you have like a printout usually which says this person has this disease. But so deep learning has solved a little of this. Deep learning has solved, let's not worry about that which exact pixels, because of which exact part of the lungs. The doctor is saying this guy has bronchitis or typhoid or any other disease. The deep learning will learn by itself. It's just you need to provide it with an X-ray. So, but still you got to have a labeled data set saying that this X-ray has this disease, this X-ray has this disease, and you got to have a large library of this data, because deep learning then requires a humongous amount of data that it will by itself figure out that why for these type of X-rays the doctor is saying this patient has bronchitis or typhoid or whatever. So supervised learning and unsupervised learning, all this craziness in AI is because of this unsupervised learning, where all you need is just data, okay? And the unsupervised algorithms by themselves, they will figure out what the label should be, okay? All this chat GPT, everything is unsupervised. They are just throwing a lot of data, and somebody has sent an on chat GPT about that you prompt about Israel and then you prompt about Palestine, because it has learned from the internet. This is what we also need to understand. It is not that it is just, it does not have any emotion. It has learned from the internet. Even if you talk about Pakistan, you'll find a lot of negativity about Pakistan. Okay, a lot of negative about Pakistan army, a lot of negative, because this is what is there on the internet. And it has an unsupervised learning mode. It has learned what is there on the internet. Okay, because internet, whatever it says, it has just learned, and whenever you prompt it, it will say what the internet says about us. So that's something more dangerous, that the way we will be remembered by these tools is not good, because we hardly have any good things on the internet about us and about, you know. So that's the challenge as well. So supervised learning is where you have a label data, and people have been just working on like very interesting applications, or perhaps useless applications as well. But you will find a lot of these on the internet as well. For example, this is where, so they have like total bill amount is what, and whether it is a delivery or a pickup, and they have collected all this data, that your order, and for example, you have ordered something small but you are generous, you have given him this tip, it was delivery, and you have ordered something very expensive, but still you have given him 50 rupees, for example. Or you have ordered something small, but you have given him a good tip, and you have ordered something big and you have given him good tip. Okay? So they have labeled this data so that they can just predict. And then I found something even more interesting, that they have now, because they want to precisely know this customer coming and ordering whether he's going to give me a tip or not. If he's going to give me a tip, how much tip should I expect that he will give? Okay, so they have now more things into the data. They say for the current customers, it's a labeled data set. They say total bill, what tip was given, gender, smoker or not, perhaps people who smoke gives more tip, day of the week, lunch or dinner, number of people on the table. So they are just now putting more data to be more precise, that expecting that this guy will give me this much tip. Okay, if it is a weekend night and he's smoking all the time, and, so you may think that he's going to give. So they have now these different predictors based on the different type or the time of the day, or on which day somebody is in the restaurant. So this is also the distribution, generosity distribution. This is how people are spending time, is kind of a gamma, or kind of, and this is the tip that they are going to give. And so both are kind of Gaussianly distributed. Then is unsupervised. Unsupervised, you just throw the data, and the let data basically get clustered, and then you try to make sense out of those clusters. For example, here is this is a data year in a company of all the employees, and there are people who have spent a lot of time, but they still only make this much money. They are not favorites, and then there are some favorites, very little time, and they are making more money in the company. So apparently two classes where you could figure out, yeah, I want to be this guy who has spent little time but making more money, or maybe this guy who has spent little time making more money, and not obviously this guy who has spent all his life and making only this much of money. So this is, and then is another interesting thing that I found was annual income and spending. If a digital economy, you know, there are people who make more money, usually they don't spend, okay, because all the time they are busy in making money. But people who make little money, there are some who will spend even more what they are making. Okay, so this data now, it automatically get clustered, and you can put some meaning into every cluster. You say, for example, these people are very careful in spending. These people, like standard people, are just spend half of the money they make, or they have little savings, and careless, sensible. Okay, so you can have like different people having different, and if you are selling something, you say this is my target, people making more money and spending more money. So I want to identify who are these people who are rich and they also spend. So I should just target, and if it is targeted campaign I am running on, maybe on sending SMSs, and so I should just target these people. And this is all unsupervised learning. You have somehow this data and you throw. So I've done a lot of work, and I'll be showing you in end of the class. So in supervised learning, as I mentioned, you got to have labeled data, and then you train a model, and then the model says, yes, this person has cancer, for example, And then you have a training data set which tells you no, the doctor says this MRI does not have a cancer. So you say, oh, there is an error, and then you retrain the model. So retraining the model is important. But in unsupervised learning, you have data, it goes to the model, and model basically is something as I showed you, the clustering, or maybe just generating some of the. So if you have a model, you can generate new data, and that is where the generative AI comes into play. And so with unsupervised, logically we move to generative AI. That how if you have a good model, you can generate more samples, newer samples.
What is the probability of correctness involved in
Probability of
correctness?
probably
Accuracy.
here at least on the data you have, you can find out the accuracy. Here you cannot find out the accuracy, though you can take this data and also put it here to check the accuracy of your algorithm, because it is labeled, and you say whether a clustering algorithm can cluster a particular label into a class or not. Okay? So kind of you can check the accuracy of your algorithm. So it is not that you cannot run unsupervised learning on labeled data. Yes, you can.
What about, for example, uh, if I say that in unsupervised learning you need more data as compared to supervised learning?
Because unsupervised learning has so many different algorithms. Not necessarily you need more data. I think I'll show you some examples where with very little data still you can do the classification. But for generative AI, yes, you need a lot more data. For generative, making a model which can generate more, you need more data. But for unsupervised learning, it depends upon the application, whether you need more data or not. Okay? But remember, this is important that you can basically have some labeled data as well and see whether your clustering algorithm can separate them into different clusters or not. And we will see that too. Okay? So GG,
Am I
please.
audible, sir?
Yeah, yes.
Sir, I have just small question. Like, is there any way that we can tweak the output? Like, in case of model is like generating the output for us, whatever the data we are feeding, and we don't know whether the output is right or wrong. So, is there any way like we can label the output so that the model can learn from it? Like, I can see in unsupervised learning, there's no way for it understand like whatever it is generating is right.
Yeah, no unsupervised learning algorithm takes an error as a feedback and adjusts its parameters. For that, then you have to go to the supervised learning algorithm. If you have labeled data and you want labels to help you in tweaking the algorithm, then it is supervised learning. Unsupervised learning means that there is tweaking, but tweaking is based on some parameters which are just are specific to an algorithm and data. I'll show you those parameters.
Right. So it's just like I'm pouring in so many X-rays into it, and it is going to give me, I would say, a result like somebody is having some disease, maybe ABC or something like that.
No, it will.
Similarly,
GG.
similarly, I can arrange a doctor, and doctor can let this algorithm know that the output that you have generated, it is right or wrong, and then I can feed in the output.
Yeah, what you can do is you feed in a lot of X-rays and let this to put those X-rays into classes without knowing what each class means. Okay, precisely this is what you are asking. So now you bring a doctor and ask the doctor that, look, my unsupervised learning algorithm have created 10 classes. Out of the X-rays, it has read, and please tell me that what each class means. And he may come and says, this means bronchitis, this means typhoid, and then he labels that class to a disease. Yes, this is something which can happen. Okay,
Right.
so you can, and this is precisely what an unsupervised learning is going to do, that you don't have labeled data. So what you do is you just throw all the data, make classes, then bring someone, as I showed you here, that so now somebody has once looking at all these clusters, and somebody saying, I think these are the people I should target for my campaign, because these are the people making more money. And the algorithm has no such knowledge. Algorithm has just made them into different classes. And you can also tell that in how many classes you want this data to be partitioned, or you can let the algorithm by itself, okay, partition them into multiple classes. So we'll see that how this actually happens.
Sir, when we say unsupervised unsupervised learning, so and most of the time you say internet data. So do we put any boundary? For example, if I say health domain, so I need to put something in a boundary that all
Yes.
health data I need to put.
Yeah, that's what the people are doing. Like large language model, they are fine tuning on health, for example. So now they are just only feeding it the health data, the books and the data, and then they take that model only for healthcare. For all the radiology reports, for example, they say, I want you to create a radiology report. So you make it learn a specific data, and that is where everybody is jumping on this because for example, our interest is we have an office automation system for a large enterprise, and I want to build the LLM into the office automation system. They want to say they want to create a memo or a signal or a case, so they don't have to actually write it. They say a signal which should just inform everybody a death of a senior officer, for example. So we'll just create a very nice message, okay, and then the signal goes everywhere. So you don't have to actually type anything. Okay, so this is a specific application, and then so you fine tune a large language model for a specific application, and that's what we are also doing it here as well. We're just fine tuning it for a specific application. Yes. Okay, so this is a very interesting topic. You must have heard this term political engineering. Okay, so let me tell you how you can do using AI do this political engineering. So always in nature there are hidden patterns. Nature is not chaotic. This is the whole the premise of AI is that nature is not chaotic. There are patterns, okay? Because there are patterns, so you can make use of those patterns. If you can find those patterns out, and usually they are hidden. Because they are hidden, so you cannot just, by looking at them, you cannot. You got to have special algorithms which would extract these patterns, and then you make use of these patterns. So all intelligent people or the algorithms, this is what they are doing. That nature has patterns. And unsupervised learning can also help you to extract these patterns. For example, I'll give you an example of America, and then I'll talk about Pakistan. In America, there is a divide. So usually in every country, there is a divide. There are people who are liberals and there are people who are conservative. Like Modi is conservative, Congress is liberal. The people who are conservative, they just stick to their values, stick to their belief. They are not open to new ideas, new things, new people. So they are not even, to new philosophies, and so they are just they stick to what they believe. So they are called conservative, and then there are others who are we call them liberals, that they are open to new ideas. They are open to new people coming in their country, for example, and living. And there are others who say no, throw them out, and So usually in every country you find this divide. In America also there is this divide where the Republicans like Donald Trump and George Bush, and these are all Republicans, okay? And then Clinton and Obama, they are Democrats. That's why a black person could become the president of the United States. But it will be difficult from a Republican platform to have somebody who is black to even become a candidate. So because they are liberals, they could accept him to be their candidate and voting for him, and so because the mindset is liberal. So usually, I have been observing American election, okay, like previously this is 65, and one amazing thing is usually all these are connected. If you see this, so this is a connected strip of people who voted conservatively to conservative candidate, and there may be somebody who is though on Democrat candidacy, but he may still have conservative views. He's not a liberal, so he's on this side. So that's why they have debates and people are asking questions for others to find out his mindset as a president of the United States. So, but it is in 1964. And then in 1968, somebody from Alabama, who was governor of Alabama for 4 terms, he contested election as an independent candidate. So he won that strip of conservative, okay, because he was a very, very conservative person. He was pro-segregation, that blacks should be separate. They should have, separate colleges, universities. And so he was pro segregation, whereas the entire America was moving away from segregation. So you can see that all these people who were conservative, they voted for that guy. Okay, all these states, connected states. So usually this is a connected region for somehow all these mindsets, views, they have something to do with the place where you live. Okay. So here is Nixon coming and just winning over the entire America, and then so they have like Carter coming in and getting this, and then again Reagan came and he won. And so though he was a Republican, but he is considered as a very liberal person, Reagan. So everybody voted for him almost. Okay. So then the Bush came, and here now we start seeing a divide in America. So, and interestingly, it is this part and this part. Okay. They are more liberals, and this part is always, Central America is always conservative. And I have also realized it also has to do something with the seaport. The new ideas, new items, new things, they always come to the seaport and they get adapted to it, like Karachi and Peshawar. Like Karachi, you will find people are very open to new ideas, new fashion, everything, gets to Karachi first. Okay? So you will find them more liberal. Then once you're traveling upward towards Peshawar, you find more conservative people as you are moving up. So there is a lot of connectivity here. So, and this is now you.
One reason could be that many people visit these areas.
Yeah, because many people visits, everything new comes to them first.
In Karachi, I think
Yes.
you can say mini Pakistan.
Yeah, it is mini Pakistan. Yes. This is one of the reasons that people also come, and or people start moving because there people are more acceptable and they are more welcoming to people coming from other places. In New York, you will find almost everybody, and because perhaps, but living in other part of the America, which is more conservative people, is difficult. Okay, so that's perhaps, and you see the same trend in 2000, you see the same trend, and there are few states which they say that they flip. So they have this tendency where you don't know where they will go. It's like 50-50. So their uncertainty is maximum. So they even only focus on these states. In American elections, they're only focusing on states which can turn on any side because they have maximum uncertainty. They have almost 50-50% chance of they voting Democrat or they voting Republican. But this is 2008, 2012, 2016, 2020, and this is the last election. Okay, and as you can see, it's not changing. This part of the America, this part of the America, and this part of the America is not changing. They always going to vote. They are liberals. They are going to vote, and there are more and more people who are now coming here, the Pakistanis and Indians and Mexicans, and because they are more acceptable. And like few states where the actual election is only in few states where they see that they can just turn on any side. And you can, within the state, you can see the areas, and they all are connected areas, usually. So they are kind of connected areas, opinions, and all are connected areas where large population, city centers, they usually vote Democrat, and rest of the America, as you see, is more red than blue. But the blue are the population centers where many people are living. Now, let's come to Pakistan. Okay, in Pakistan is almost same. Once the people who are voting one way, they are really connected areas where they just vote for a particular political party, their particular affiliation. And then there are definitely areas which would always vote. They are so staunch supporter of a political party. So in Karachi, you start moving towards interior Sindh, so you'll find, people just blindly, they will just vote for Pakistan People's Party, for example. But once they say political engineering, what is political engineering? Political engineering is clustering. Okay? You say, okay, this is party B, I'll not name a party. This party B, it is 55%. Okay? And this also adjacent constituency goes to B, to B, to B, to B, to A, to A. Okay? And you can cluster it in a manner that this thing still goes to B, but instead of 45-50, it goes by 80 and 20. Okay? So you put most of the voters from B, which are voting for party B, into B, because they'll be connected. And you create another constituency where, and based on the historical data, you know that. So this is called, they say, naye halka bandiyan. So you can make new halka bandiyan in a manner where you cluster those who are voting. So no matter if somebody is winning for 1% or 40%, you don't care. He's only winning one seat. So you can always do this political engineering through clustering and have, the new set of constituency where you make, even if you want to make him lose or make him win based on all the previous record you have of every place where people are going to vote, every polling station, and you see that how that particular area it votes, and you can do this political engineering through clustering. So clustering is important. This is the work of one of my PhD students, and actually where we work on dengue fever. Okay, and we were finding out hotspots of dengue and also finding out reasons that why dengue spread. It was not in Multan, it went to Multan. It was not in Pindi, it came to Pindi. It only started in Lahore. And then it came to Peshawar. And so there were so many casualties in Peshawar. So one of our case students, Rabia, her husband was in a government position where we could get this data, dengue data. And interestingly, so we made all these clustering and hotspots. And then we were trying to figure out the reasons. So the correlation, remember I told you, like the external factor. And what we figured out from the external factors, that wherever there is a metro project, that dengue will go there. It was just amazing finding. Okay. Wherever there is metro project, the dengue is definitely going to go there. It went to Peshawar because of the metro. It came to Pindi because of the metro. It went to Multan because of the metro. It's a large construction project, and because most of the cases were around that area where they do the digging and the raining and the water, and so that was our inference based on the AI, purely AI, just putting external factors, finding out what correlates with the hotspots that we were creating. So clustering is important, and I'll show you some of the other work that I have done, maybe 5 more minutes, and then I'll take a break. So machine learning, as we mentioned, that you have primarily 2 goals. One is you are doing a prediction, okay, and this is where you fit in a mathematical expression into the data, and once you have a formula, then you can see that where this formula is going to go, okay? Where this formula is going to go, and this is about anything, the stock market, or so anything which has time series, number of dengue cases going up. And so if you can put a formula into this, then you can plot it and you can make a model. So this is about putting a formula. Usually in regression, we try to put a straight line. Many phenomena are just moving, and you have to find a straight line which minimizes the error in representing these points. But if the trend is going up, then you have to put another mathematical function. The other one is clustering, where you collect the things which are similar. And why this is possible? Because the nature has a pattern. Only because of that, the clustering is possible. It is random, then you cannot make clusters, because always there are going to be patterns. And because there are patterns in nature, clustering is going to reveal those patterns to you. So they will not be visible otherwise, but clustering will reveal those patterns to you. This is the objective. Divide the objects into groups. Within a group, they definitely are going to be more similar than they are from the outside. And this is where you can bring an expert and say, now label every cluster into something which is meaningful in that particular domain, So data will just, you will see that it'll start, if you represent a cluster with a different color, you start seeing all these colors. If you say, okay, this is how this data is arranged. So these are, so you split and you have centroids for every cluster. You got to have a similarity, and clustering depends upon similarity. You change the similarity measure, the clustering, the whole objective will change. Okay, so whole objective is based on the similarity. If you are making cluster in this class on the age, okay, so definitely it'll be different clusters. But if you are making on income, there'll be a different cluster. Okay, if you are just making based on where they live, there'll be a different cluster. So whenever you change the objective and the similarity that you want, a similarity measure is basically the way you want to see that how things are. And you can have like different types of clusters as well. That is what we were doing like different similarity measures and creating different clusters, then finding correlation among them. For example, we have done a lot of work on communicable diseases in Punjab, that there is diarrhea and there is dengue and there is this and there is that. And then their pollution itself, the water quality itself. So where are the water sources, where they are polluted. So you have totally a different cluster, then you have another cluster, then you have another cluster, and you have layers of clusters. And then you're trying to figure out that why these set of diseases are happening in Muridke, and then they are happening in somewhere in Peshawar, and then somewhere in Sindh. The same set of diseases happening, and then you figure out, so there is industry. Apparently this type of industry, apparently this is how they're polluting the water, and this is apparently, without actually having a measurement on the water, you can say that it is because of this reason that you see the same set of diseases in clusters in different part of Pakistan. So that's the fun part of clustering. 4 more minutes. So usually k-means is, this is the very first thing I coded on the parallel machines once I was doing my PhD on 8x8 processor, because it's computationally very intensive. Clustering is computationally very, very intensive algorithm. Why? Because we can only display it on a 2-dimension, but remember, data is not 2-dimension. If you have 100 features, then you have 100-dimension data. Okay, because we can only represent a 2-dimensional, you may think that, oh, it's such a simple thing to do. And then data is humongous. So clustering is an NP-hard problem, like it exponentially grow data. Okay, sample like height and weight, 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 height and weight. Okay, so this is the data. So here is the height and here is the weight. And for everybody, you plot height and weight, only 2 features. Okay. So this is your data representation. And you want to see, is there any pattern in height and weight, the data that you have? Or they are just uniformly distributed. If they're uniformly distributed, obviously there is no point in making them into clusters. Clusters are only if they are not uniformly distributed. Then you make them into clusters. So you start with, can I divide them into 2 groups? Start with, obviously this is 1 group. Can I divide them into 2 groups? So you randomly you say, I think I can divide them into 2 groups. So you randomly select 2 points. Say these are the centers of the 2 groups. And you can put them in anywhere in this 2-dimensional space. And you say, this is group number 1, this is group number 2. And now you want magically, they move towards a group. Okay, magically how first you say which one is closest to this? Is this point close to this or close to this? You say it is close to this. You say okay, I assign it to this cluster. Is this point close to this or close to this? I say it is close to this. I assign it to this cluster. And find that those points which are closer to this are assigned to this cluster, and those points which are closer to this are assigned to this cluster. So you do the first assignment. And now you find the average of all these points where the x and y and divide them with the total number in this cluster. And this point will move to now this new center, and this point will now move to this new center. And now you run this again. Every point you have to calculate its distance from this center and say, is it close to this? For example, now this point has become closer to this, not closer to this. So you reassign it to the other cluster. And similarly, this point now is close to this, not close to this. You assign it to a different cluster. And again, you have a new set of assignment. And again, you find the average and find a new centroid. The new centroid will move here and here. And you keep running it. This is, you're doing it for 2. Okay? And you find out at one point there will be no change in the points. You say now there may be 3. Okay, now you do the same exercise for the 3 groups because you don't know how many groups are there in this data. You say there may be 4. Again, you do the same exercise for them. There may be 5. Okay, so you have to say that for how many groups you would like to see that the data may be split into this, and then somehow you have to decide what is the natural clusters in this. And so there is a way that these are the natural cluster. Perhaps you should have these many, but first you have to do this exercise of saying 2 and 3 and 4 and 5 and 6 and 7. Every point has to be compared with every centroid. Okay, every point in every iteration. So that is what it makes it computationally a very, very intensive problem to solve if you have a humongous amount of data and a large number of clusters that they can make. So let's take a break. If we can take just 20 minutes and then कितना 20 मिनट काफ़ी है 20 मिनट्स की ब्रेक 10 मिनट आखिर में ले लेंगे ठीक है 20 मिनट्स
So for future references, do you believe that we should be learning Python or something like that, or work out like a PhD and those things?
I think you only need to learn enough to understand the code, and if you need to do a little tweaking of the code, but not like writing the code yourself, there'll be, from my perspective, there'll be just waste of a lot of your precious time. Focus on creating ideas, learning about prompt engineering, how you basically prompt the chat GPT and the other tools. And if so, honestly, I think that just programming, perhaps especially the Python, is so concise that chat GPT does a very good job. So
no, sir, I get it. I was asking related to like a future perspective.
Even
like
for future, even for your PhD also.
Industry.
Maybe for your PhD, just you learn enough to augment what ChatGPT has generated for you. But always take help. Don't start just writing it yourself. Take help. Let's see what ChatGPT has done for you. And then if you want to augment a little on that, so perhaps that should be enough for you to. And as I mentioned, I have even learned how to do assembly language level programming. And then once we started coding in C and they were good compilers. The issue was with the compilers. The compilers were not good, especially once I was working for Cisco system. They have this V.90 modem. And even if you can make another session, modem session in your code, you save millions of dollars for the company to have, multiple sessions on the single chip. So there the focus was to have more and more sessions, modern sessions on the single digital signal processor. So everything was coded in assembly language. Though C was there, but the compilers would do a very bad job. And now the compilers have come up to, just to mark, and now you can just generate a good code, assembly language code. Same is the case with ChatGPT. It is bringing you a level above the Python. So you just is another level of abstraction where you got to learn how to prompt it to generate what is good for you. But then if you're doing a PhD, perhaps learning will not hurt. That if you learn and you could also augment it in any which way you want. So you should also do that. Python is very easy to learn language, honestly. ठीक है ना? So let's start. So I told you about the k-means, and here is an example that then you have to decide that how many clusters you are going to keep. So this is not really a fixed science that so these many clusters you are going to get. So here is the algorithm. Usually you have all these data points. So let me take. So you have these data points and they will be usually d-dimension, okay, not 2-dimension. You can always do PCA just for your own visualization, nothing else. But don't just plot what, so you got to prompt ChatGPT to do the PCA and give you only 2-dimensional data for you to plot and see. Otherwise, what ChatGPT would do, it will just take first 2 features and it will plot the clusters, and that may not look very pleasing. So usually data is d-dimensional data. So every x1 has d number of features. Okay, but once you want to visualize a cluster, it is always good to see it in 2 dimensions. So you must remember that this is not true representation of the data, because you cannot visualize something which has 10 dimensions or 100 dimensions or 200 dimensions, or for example, for the word embedding, it is 300 dimension vector. So you cannot visualize a 300 dimension vector. So this will be with a lot of compromises what you see in a 2-dimension. Also remember, because a 300 dimension, there is a reason why data is 300 dimension. Otherwise it would be 2-dimension data. So just seeing a 300 dimension in 2-dimension means a lot of compromise that you are doing. So you must know that. So once you are plotting, so this is what each point, let's say you have point x1 is this, let me just do this, x1 circles, x1, x2, x3, x4, x5, x6, x7, x8, x9. So you have n data points and k clusters, and k you need to decide the optimal k for this specific application. And this is what it will try to do, inertia. It will minimize the inertia. And inertia is that once you make clusters, so every point in a cluster has some distance from a cluster head. Okay. For example, in this cluster, so this is some initial assignment, but these are the points which are away from this, and then some of these points are here. So this is a cluster which is shown in the blue color, and this is another cluster which is shown with the, definitely it is an intermediate iteration, which it is going to improve with the passage of iterations. But inertia is that you sum all the distances of every point in a cluster with its cluster head and add them together. Okay, and then you can take the average, or just adding them is also fine. And similarly, you add a distance of every point in this cluster with the cluster head and add them together. Every point in this cluster, in this cluster, in this cluster to the respective cluster heads, and add. This will give you a good measure. Definitely you are going to get a bad measure here, because some of these points are quite away from the cluster head. So this large distances, once you're going to add, you're going to get a big number. So, but once you again find the assignments, or maybe your number of clusters are not right. Okay, you may have like so many clusters. So once you are trying, you will get this E, or J, or which is the inertia. So every point is in k-means is only assigned to one cluster. In some techniques, every point is assigned to every cluster. Okay, with some probability distribution, that it is to this cluster 80% probability, but with this cluster 20%, with this cluster this much. But here you got to decide that every point is to be assigned only to one cluster head. So you k initial centroid, assign points to nearest centroids, recalculate the centroids, and keep repeating these steps. So that's very simple. Keep repeating unless It's stable, gets stable, it is no more changing. Okay, well, I'll show you some of the animation. So it is guaranteed that k-means algorithm will converge. And it will depend upon your initial choice of centroids, number and where you start. Okay, so you may get different results based on that. So here is an example, it's an animation. So these are the initial centroid. So these are the clusters which goes to red. And now you recalculate, just keep looking at this. Now you again calculate, it has moved here. Now you again calculate, okay, it has moved here. And here was the partitioning. Okay, so the centroid will start moving, and if you look at this, slowly but surely they will be, it will extract the natural clusters from the data. Now this is the natural cluster here, these are the natural clusters. Okay, so you have some initialization, okay, and then you assign the point which is closest to one of these to that cluster, and then you recalculate the centroid. And then again do the reassignment, that's a computationally intensive. Then again you find the centroids, and once there is no movement of points, you just stop there. Now you have, with this, that you started with this, you have reached to a point where it has assigned every point to a cluster and there's no more reassignments. This is a simple example. Let's say it's a one-dimensional line. You have 8, one cluster, and there is another cluster. So you assign this point to one cluster and all these points, and this is a cluster head assigned to this cluster. So you find out the average of these. How do you find out average of this and average of this? By just dividing it 1, 2, 3, 4, dividing it by 4. And this dividing it by 8, it will remain 8. And this average will change. This is the centroid of the other cluster. So it is now 0.5. So 0.5 is here. Now again, start checking the distance. And once you start checking the distance, you will find out that this 5 is closer to 8 and not closer to 0.5. So you assign 5 to 8. So you make a new cluster. And here is a new cluster. Now 5 is assigned to 8 and rest are assigned to the other cluster. Now you add again and divide them by 3 and add this and this, dividing by 2, because now there are 2 points in this cluster. And so you get a new cluster head. So here is -1 and 6.5 is a new cluster head. So now you have a new cluster head which is here and a new cluster head which is here. And again you make the assignment. Now 3 will move here because 3 is closer to 6 point this and away from -1. Okay.
So can we clustering based on the features? For example, if we have 10 features in a very big class, so can we say that distribute it to 10 clusters based on the features?
No, not really. It is never. Otherwise, if like you can do it just based on 10 clusters, you have 10 classes, it means every cluster is just a class. So you don't have to really cluster. So usually this will not happen, that if you have 10 features, so they may not be just 10, they may be even more or less. So how you figure out, I'll tell you that. Okay. So now this looks like a natural cluster. Okay. So this looks like a natural.
Is it not possible to have an additional cluster as well? Because it seems that
yes,
5 can be one cluster, 8 already.
Obviously. So there is no fixed thing. You started with k is equal to 2. Now there is a criteria, and the criteria is called that you basically find out the distance of each from the cluster head, and find out that the average, and that'll give you a number. Then you say k is equal to 3. As you are saying that k is equal to 3, you should have this should get into one cluster. This will go to another cluster, this will go to another cluster. And again, you find out the distance between the points and their centroids. And you plot that. Then you can also say, why not to have 4? Why not to have 5? What is stopping you to have 5? Okay. So that's what usually you do. Okay. So this is one way of clustering. And so this is how you just doing iteration. And this is yet another example where you have some initial points and assigning points. There will be basically a partition that there are 3 clusters you are assuming. And this centroid, because more points are here, once you take the average of all these points, definitely will move towards this. And this point will also move randomly because these were randomly selected points, and this will move towards this. So here you see that movement. And now you again, the green points, you add them together, and the blue and the red and the cluster heads are moving, and then it becomes this. So there is this website if you want to try this out, and especially the same thing. So you can just click here, it'll take you to a website where you can select the number of cluster points and see that how these changes. I mean not. So, so many, as you yourself mentioned, for large data, many clusters are possible. Many clusters are possible, and you don't know the exact size. So you don't know the exact size. Many clusters are possible, and so the optimal solution is intractable, difficult to achieve. Allocation depends upon the choice of initial clusters, and you don't want to have like thousands of clusters or hundreds of clusters. You want them to have like few clusters, and K is chosen visually using the knee method. So this is the method. The knee method is here where you have total within sum of squares. This is a cluster head, and distance of every point within the cluster, and then there is another cluster, and you calculate this distance. Okay, initially this distance is going to be very large. Okay, for if you have just one cluster, you are going to have this large distance. Now you have two clusters, you find out this, and you will find out that as you have more clusters, this distance will definitely reduce. Okay, because now the cluster, because if there is only just one cluster head and there are points everywhere, so this average distance is going to be large, every point to this. But if there are cluster of points here, cluster of points here, and you have a point here and a point here, this distance to the cluster head will reduce definitely. So once you are doing this, you will find out as you are increasing the number of clusters, the distance from the cluster head in each cluster, this accumulation will reduce, and then it will almost stay the same. Okay, so there will be a knee, and knee should help you to decide that perhaps 3 clusters are good enough. So that's why first you have to run it for a number of clusters. That's what the chat GPT is also going to do. And then visually you will see this is the knee. So you decide from whether you want to keep 3 or 4 or 5. And you say, and then you again retrain, recluster by giving that you want these many to. So this is, yeah, elbow method, knee method is the same. So this is how you do the, look here, this is like, again you see the same, the points are changing, and so there's many animations you can find on the internet, many utilities. This is another where you have cluster heads, now it's changing. This is about the number of 3 clusters and how, now there will be no change. So here, so it'll just stop changing, and then it'll just starting it again. Same is here, that here you are randomly selecting the centroid. Here you may have some intelligence that this is where the most of the data is, so I have like these 3 centers, and this is the accuracy of accuracy means the same. If they are already labeled points, then you can also find the accuracy as well. So there are many like these. So this is the method where you have now 1 cluster, now 2 cluster, now 3 cluster, 4, 5, 6. As you have more and more clusters, the distance is the 6 and 8 and 9, and then you say, okay, here is the knee should say that you should have like 6 clusters or 5 clusters. So this is what I did to ChatGPT. I asked ChatGPT to plot the k-means cluster assignment in 3D, taking most appropriate 3 features from iris data. Plot the k-means cluster assignment in 3D, taking most appropriate 3 features from this iris, and you compute the k-means clustering algorithm for some other data set as well. So I asked it first to use the iris data set. And because iris, remember, is a labeled data set, okay? So it again is using sklearn, and cluster and k-means, importing the k-means, loading the iris data, and loaded the iris data, loaded the data. And
Sir,
then
we already have the CSV available on
yes,
Hierarchical as well.
yes,
One way of doing it so that
precisely,
save in the Google Drive and you can reuse it.
precisely, you can reuse it 100%. Now look here, it is saying for I loop do from 1 cluster to 11 clusters. So it's going to 1 and then 2, then 3, then 4, then 5, then 6 till 11. So it is having number of clusters is I. So it'll make 1 cluster, 2, 3, 4 and maximum iterations, and this is where it does some smart guessing. And then it just plots that, okay? It plots that and then it asks you to see that how many elbow method, number of clusters. And then it says, because it knows about this data, it says elbow shows 3. So let's use 3 clusters. And then it runs this again. Now optimal number of clusters is decided. It is 3. So it says use k-mean again. Now on these many number of clusters, 3. Okay. And it just starts with this. It do the prediction. Okay, and then it also can tell you a little about the accuracy because it's a label data, so you may want to, but otherwise it's just label. And here is the k-mean clustering. So it is like divided into 3 clusters because there are 3 types. And it is only showing not the PCA, rather it is showing on the sepal width and sepal length. Because I told it just show it on any 2 or 3. There is also another figure which shows it on 3. So here is the elbow method where it started with 1. Then there are 2 clusters. Then there are 3 clusters, then 4, then 5, then 6, then 7, then 8, then 9, then 10. Okay. And this is that distance measure, which is the every point to its cluster head, squaring and then adding. So you can visually say that 3 is the most appropriate number of clusters that you should have data with 3. So this is where I ask it to plot it in 3 dimension as well. So I prompted it to plot it in 3 dimension. So 0, 1 and 2. So it is sepal width, sepal length, and this is another one of the other parameters that it used. So so primarily this is what it is. And then important is, as I started this topic by saying that it is subjective, that how do you want to group people? For example, you want to group it as a family or as an employee or female and male. So similarity measure is important. And there are so many different similarity measures. Euclidean distance is just one of the measures, but then there are other measures as well. Okay, so you got to have some way of measuring similarity and dissimilarity, and points in the cluster are similar based on how do you define similarity. Okay, and across clusters there may be cosine similarity is very different. So you take cosine of the angle and you say, okay, I want to use cosine similarity in clustering the points. And so so this is important, that how do you basically measure the distance between 2 points. Okay, this is 1 point, this is one. Easiest is that you have Euclidean distance, but then there are other distance measures as well. So the clustering says you may come up with any similarity measure, but try to make sure that it adheres, that measure adheres to these 3 properties. One property is that a measure, whatever measure you have, from point A to point B, if there is a point X and a point Y, and you now compute a distance from Y to X, it must give you the same distance. Okay, it must not be a different distance if you're going X to Y and Y to X. So this is the first similarity measure. It asks, try this, otherwise Alex may look like Bob, but Bob may not look like Alex. So this must not happen. The other one is, if the distance is 0, then they should be the same point. So 2 different points should not have 0 distance. And if there is an intermediate point, like you are X, so it is X and Y, whatever measure you are selecting, and you have a Z, then X, Y must always be less than distance with Z and Y. And there are interestingly many examples which will not adhere to this, especially once in a spell checker, once you are writing. Okay. And you must have seen it, you missed something, it will insert something, a letter here, what you have missed. Okay, so it is always computing a distance with the closest possible choices. So what can happen once you are typing something? One is that you have missed a letter, so it got to insert a letter. Okay, insertion has some cost. The other is it has to replace something that you have actually written E, but it should have put an I there. And you have left a space, and there was no space. It has to just fill in the space. It has to delete something. So insertion, deletion, and correction. These are the three different things, and you can associate a different cost while you are comparing its distance with the choices you have. Okay, you may say insertion is a cost of 3, deletion is a cost of 1, and correction is a cost of 1, for example, or cost of 2. Okay, now what you write incorrectly may matches to different things, and based on the behavior it knows missing a letter may not be very common. So if somebody is adding another letter, one option, so keep it away. First try to just correct, and if it's just a spelling mistake, just correct the letter number, keeping the number of letters same. The other one is perhaps another extra letter, so you delete, so you have more cost, more distance. And the only option is that you are inserting another letter, so you increase. So first it is going to match with something which only needs correction. Otherwise, it may just give you. So this is where some of these properties will not satisfy. Okay, because now you have for the same letter that you have typed, you have assigned a different cost to a different thing. And once you are computing a total distance, and now remember every point in the space has, so if I write, for example, I was always misspelling it, hierarchical, okay? So I have misspelled it, 100% sure, okay? So I don't know, perhaps here you have A or whatever. So now it is going to compute a distance with all the possible options which are going to be there. But replacing a letter, maybe I've assigned it a different cost. So maybe this E, instead of E, if it is an A, so I'll just jump to that first, okay? And then it'll say this is the closest, so it'll give me that option, which is the closest option. But we also need to understand that similarity measure could be anything. So this is also a similarity measure, whether with all the words that you have possible options and you got to compute distance. So it is not Euclidean distance. It does not make any sense. So distance has to be in terms of either insertion, deletion, correction. Okay, and you got to assign a cost, and then you find a distance, and then you find which one is closest from this perspective. Okay, so that's the thing, that you may have like different types of distances. Usually it is a d-dimensional space. This is a Euclidean distance, which is the easiest. If you have a d-dimension, so every feature you subtract with the respective feature of the centroid and square it and then sum it. Okay, if there are 10 features, so feature by feature you take the difference, square, take the difference, square. This is where you have 1 over p, p1 over p. This is called Minkowski distance, where it is not square root has here 2. So the power is 1 over 2. But you may have all these powers p plus power p, and then you have 1 over p. And then you may have just Manhattan distance, which is the absolute distance. And I'll show you what. And then you may have this h infinity distance, which is the maximum of the distance in the respective features.
Farthest points.
No, farthest feature. This is like if you have 10 dimensional, okay, xi minus yi, from I goes from 1 to d. Okay?
You chose which is the most far.
The feature which is the most distant. The feature, not the point. Okay? So if for example, if you have a point here, and this is 3 and this is 5, so you say 5. The x difference is 5 and y difference is 3. So here is an example. Euclidean distance is 4 square plus 3 square, another one. Okay, so this is the Euclidean distance. Okay, and if they are coordinates, then you need to have this minus this whole square plus this minus this whole square. Manhattan distance is you go in x direction, and especially if you have for example, the Euclidean distance will not make sense if you are finding travel from A to B. It will not make any sense because there may be road, there may not be any road which goes from A to B. So there may be streets and So here, obviously this distance will not make sense. So you got to have some other distance measure, even if you are saying how close one thing is from the other. So similarity measure, the Euclidean distance may give you a wrong impression. And that's what the Google also does, that it finds actually the distance on the roads, and you may give you a good approximation. Manhattan distance may give you a good approximation of going from point A to point B. And maximum is 4, so this H infinity distance is 4. This is called Hamming distance, and Hamming distance is the bits that are different from other. So sometimes in digital communication, we find out the Hamming distance, that what we receive, how different it is from the other, and the distance is the Hamming distance. Again, no Euclidean distances will not make any sense. So similarity measure could be anything. So you got to see that what type of similarity measures you should have once you are clustering things together. Okay? So that's, and this is something where you have an image and you are doing clusters based on intensity and the clusters based on color. So what you do is that everything has, every pixel has some color. Okay, so you are moving in another dimension. Okay, for example, if it is RGB, red, so for every pixel you plot its value of red. Okay, some are more red, less red, so you do this. Red color, okay, and remember that this pixel comes from where in your image. And now let's say you want only 8 colors. 8 colors. So you divide it into 8 clusters. 8 values only, and centroid. 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 Now replace all these pixels with this value. Right? And if it is you want to do with RGB, then there will be R, G, and B. So every point in this physical image is a point in the 3-dimensional space based on its value of R and G and B. So let's say there is this point which corresponds to this particular pixel, and then there is this point which is somewhere else in this space. Okay, I just only need to remember, I need to label it that this point is coming from pixel number 2, 3, and this point is coming from pixel 5, 8. Okay, so every point is to be labeled. And now there are more points here, 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 more points here. Okay, and I say I only want to cluster them into 2 clusters or 3 clusters. I mean, there will only be 3 colors. Okay, so I say clusters. So for example, here I have put them into 8 clusters or so. So now you see this image is different from this image because they are only limited number of colors. Then I need to go back and change every pixel according to its centroid. Okay, so here is another example. There are 11 colors. So you hardly find any difference here and here. 11 colors. There are only 11 colors, and here you have 256 colors. Okay, so now what you have done is that every pixel can only be one of the 11. And how do you find out these 11? By seeing that the clustering algorithms, that you have taken this into the 3-dimensional space of RGB, you have made the clusters, and then you have come back and changed every pixel into its associated cluster head, the value of its associated cluster head, and you see that this is how it has shaped the image, and that would also help you to do the segmentation and other stuff. This thing, the clustering, this is an application of clustering that it will help you to do the segmentation. right? Maybe this is the sky, this is the water, this is so it will help you to do this segmentation. Another interesting technique of, so clustering has so many different techniques. One is this, look, spelling I wrote wrong spelling. This is HIERA. So hierarchical is, so it will autocorrect based on the distance measure, okay? So hierarchical clustering is simple, that you have them on and you group them. Those which are closest together, you group them into two. Okay, so those, and now they are closest together, group them into two. And these are closest together, you group them into two. And there is some similarity or distance measure. And now you say there seems to be, these are closer together. Whatever similarity measure you have, group them into two. And now you group them into two and you make one, and you say these are the animal kingdom. But you start with each as a separate point, and you just keep combining them together. And for example, here there is an animation as well, I'll show you. But first you go to the closest, you say these are the closest, and find out their centroid head and convert into 1 point. Okay, now which one seems to be closest? Maybe this. Now you make it into another cluster head. Now you say which one is closer. This is very far, this is very, oh, this seems to be closest. So you make them into one. Now which are the closest? You see, oh, now perhaps this seems like closest. So you make them into one. Now you see these are the closest. You make them into one. Now there is only one left. So you combine these two. Then, as I did, which was this point, and then this was closest, you make this. So if you want number of clusters to be 1, 2, 3, 4, 5, this also gives you, systematically you are reducing the number of clusters. So these are 5 clusters, as there was one cluster this, 2, 3, 4, 5. And then you combine this, so now you have, so there are 5 clusters here, 1, 2, 3, 4. 4 clusters. Here you have 1, 2, and 3 clusters, and here you have 1 and 2 clusters, here you have 1 cluster. So you can see that where do you want to stop. So here is what is happening. So these 2 points, you collect them together into one, and then you have this and then one. And so you need to decide where do you want to draw a line. So you want to draw a line here, you want to draw a line here, you want to draw a line here, you want to draw a line here. Or so this is the animation which is showing you the same. This, now this gets into a cluster. And now you have 5 clusters, this gets into a cluster, these 2 gets into a cluster, 3 clusters now. And this gets into a cluster, now you have 2 clusters now. This gets into a cluster, you have only 1 cluster now. So systematically it can have, this is called hierarchical clustering. And this is where the hierarchical clustering can just keep clustering the closest points together and keep moving, move upward. And now there are again different similarity measures. So you can come up with your own as well, depending upon the type of application. इनको वो कर दो, mute कर दें सब. So you have, one is that you see the centroid. The other one is you see the closest point in that cluster. One is you see the most distant point in the clusters. And the other one is the average. For example, here is once you are merging, so this is already merged as 3 points into one cluster. And this is again has already merged into this. Now one measure could be the closest of these. This could be a way to find out which one is closest. The other one is the most distant of these. This could be one. The other one is know every distance of every point with every other and taking the average. This could be a measure. The other one is centroid to centroid. This could be another measure. And there may be like other methods as well. Increasing within cluster variance is to smallest degree, and which is changing the variance to smallest degree. So this could be different similarity measures which you could use while you are merging. So this is closest point, this is farthest point, this is the average point. Okay, so here is the animation again. So it's combining. So and then you can go in other direction as well. So you start with one cluster and you partition it so that you have like 2 clusters like this. So you have 2 clusters, then you see which one you should partition again, which has maximum separation. So you have more, and then you can. So you can start from one, go to smaller, then you can smaller one, and you go to the big one. So this is another interesting and perhaps the easiest to visualize is the density based clustering. So wherever there is density, because if you do k-means clustering, and if this is the scenario, okay, the k-mean is always going to put a line, because its separation is always going to be a line, because there is going to be a point here and a point here. So the points which are closest to this will be assigned to this cluster, and points which are, because you are doing Euclidean distance, okay, you may come up with another type of distance, maybe polar distance, or so then you may able to retain this. But otherwise, Decian boundary is like this, Decian boundary is like this, Decian boundary is like this, which is you have centroid here, centroid here, centroid here, right? But if you have data which is something like this, so this will not, k-means will not work. Okay, so you got to decide that which method is the best method for a specific application that you have. So k-means, you need to know k, and then the other. And DBSCAN is wherever there is a dense region, you convert it into a cluster. Okay. So for these type of application, DBSCAN is a good, because k-mean will give you this type of thing. So let me show you with how it works. So here are the densities. You have like, so wherever there are dense regions, it will convert them into clusters. So very easy. Let me do it myself first, and then I'll come. For example, here is the cluster points. So you need to decide about a circle with a radius, that how big a radius you are going to consider. This is the first thing that you do, that you are going to have a circle with some radius, and you are going to move this to, okay, you are going to move this onto a point. This is, so you got to move it onto a point, and then you need to decide that how many points. So there are 2 variables. One is the radius of this circle. The other one is how many points should be there in the circle for you to say that it is a core point. Okay. Let's say you decide about 4, that if there are 4 points come in a circle, and this is the center of the circle, I'll say this is a core point. So every point which comes in the circle, I have to traverse that point to see if it is a core point or not. If there are no 4 points, less than 4, so I will not traverse, I have no obligation to traverse this or this point, okay. So I can start from anywhere. For example, I put it here, and I say here, for example. So I say, yes, there are 4 points. So now this point becomes a core point, and let's say 1, 2, 3, 4. These are the points which are with the core points. So I have a responsibility to traverse them as well. So I push them into a queue. I say these points are to be traversed. Okay. Then I go and I say, okay, I go here. I say, yeah, maybe even partially touching, I'll say, yes, this is a point. So again, 4 points. It means now I have a responsibility to traverse all these 4 points to check whether they are core points or not. So I go up and I do this. And I say, oh, I am still 1, 2, 3, 4. There are still 4 points. So I have a responsibility to traverse all the points which are coming in the circle, because there are 4 in number. So I go, because I have a responsibility to traverse this. So I go here. And now there are only 3 points. So I have no responsibility. I am not going to push this in a queue. I will not traverse this point to see whether this is a core point or not. Okay, I'll just stop here. This will become a boundary point for me then. So this may become a core point from somewhere else. Okay, so but this is a boundary point. I will not traverse it in this direction. But now if I am here and sorry, so similarly here is there is no core point. So this is a noisy point. So I can just remove it. So this is something which may be just adding noise into my clusters, and it's an isolated point. So similarly, if I go here, there is no core point. So anywhere where I don't have even a single core point, I can just remove those points, right? So the size of the circle becomes important, because I'm not going to assign this point to any cluster. So this is going to bias otherwise my distances and centroids and other measures. So I'll say not even consider these. But once I come here, and because this is not in the queue of this, so separately I'll start it with another cluster. I say this is another cluster. So I see this is here. I say, oh yeah, there are 4 points. If there are 4 points, I say, okay, for example, here 4 points. So I'm going to traverse all these 4 points. Okay. So that's how this algorithm works. And this is what I started this lecture by telling you about the political engineering. So these points could be constituencies as well. So you can see that how many constituencies you have which are linked with the same party. And you say, okay, then, so the blue are the polling stations which voted for one specific party, means the majority. The gray are, you are not interested because they voted for something else, and the are for the other party. And now you are trying to do some political engineering by clustering using the DBSCAN and finding out how should you basically redefine the boundaries to give benefit to one party over the other. So you can easily do this engineering, and I have it the same thing that I can just run and do it, the partitioning in a manner that if they are winning somewhere, so they should win with large majority. But then the other constituencies, they should have, the other party should have more chances of winning. So here is the k-means. As you can see, the k-means is going to separate it in a very different manner. Okay, it's not natural clustering because the data is such that k-means, because if let's say it says there are 3 clusters, and k-means is going to draw a line primarily. Sorry. So k-means is always a line if it is a Euclidean distance. If you may have other distance, but here is a line, here is a line, and here is a line. Okay, and also because it is here, so apparently this is the line. Sorry, this is the line, and similarly here. And obviously, so these are the lines where you have. But on the other hand, if you run the DBSCAN, and remember the circle thing, so it's just going to assign it to orange, 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 orange. And then because it's totally separate, not linked in that queue, so these are the points which were not part of the queue where we have assigned it to one cluster. So I'll just, once it is starting over here, I'll put a new color to these. Okay, so I've just written it here. So this is also, so you will find many GIFs explaining it on the internet, and also explaining what if you increase the size of the circle, or increase the number of point, decrease the number of point. So again, and then there are again ways that will help you to decide about that what should be the minimum number of points in a circle. But here are, you can see a lot of noisy points as well. So I'm just going to ignore those. And there is one big cluster which is linked. And then there is, so they all seems to be from the same group. They seems to be from a different group. And they seems to be from a different group. They seems to be from a different group. So similarly here, so different. But so very simple algorithm. Draw a circle, find out the many points, all the points in the circle. If there is a core point, you push them in a queue that you have to traverse them to check whether they are core points or not. If they are core points, again, you got to see whatever is in their circle, you got to check whether they are core points or not until you hit the boundary point. Once you hit the boundary points, you got to stop there. For example, here, you will see that it will stop, this side will stop here. I think it was in the previous, here. Yeah, look up, it stopped here, okay, because in the circle there was no core point, so it stopped, but on the other side, once it is coming, it has linked with the other one. So that's how it got into. This is what if you have epsilon is 1 and minimum points are 8. What if you change it to 0.6, reduce the circle, the size of the circle, and reduce the number of points. So there may or may not be any change. There is a change once you have reduced the size. So many other points are being labeled as not part of this, and another, it has made another cluster, because once you have a smaller circle, it may create more clusters. If you increase the size of the circle, definitely is going to reduce the number of clusters. So as we can see here, that many of these points which were part of the green, here they are not part of the green. Okay, and there is another cluster, there is another cluster, there is another cluster, there is another cluster. So it has created many more clusters because you have reduced the size of the circle and the number of points, minimum points. So same is here. So it talks about that what if your epsilon is 1 or 0.5 or 0.33 or 0.1. Because you are reducing the radius of the circle, definitely you are going to create many clusters. Like here you have 6 clusters, but here you have only 1 cluster. Okay, there are 1 cluster, there are 3 clusters, there are 4 clusters. So number of clusters are going to change. And you got to decide, maybe if it is something real data where you may have to bring somebody expert in that area to say perhaps this is the natural partitioning of opinions of people, of their health or whatever, or their intellect or whatever. So that's how this thing works. And it is also good to clean up, especially once you are binarizing things, and in machine learning you got to find out an object. So this is also good in removing the noisy points from this. So this is also the description of the same. So let me now just little time I have share you the work of my student, and this is also the same clustering. So here is only 2. Still you can figure out. So now every pixel, every colored pixel is made to be part of one of the 2 clusters. Okay, every pixel. So all those which were part of one were colored this, and the other were colored this. And this is the average kind of. And here you have increased to 5 clusters. Here you have increased to 10 clusters, and here you have increased to 20. There's also kind of image compression because instead of every pixel to be 256 by 256 by 256, okay, you have only these 10 numbers, and you can 10 cluster heads. So you can 10 means how many bits? 4 bits. So each pixel is just 4 bit. One of the 10. So you, instead of these many bits, 256 by 256 by 256, so you have reduced them to 4. So you can find out the compression 256 by 256 by 256, and just divide 4 divided by this actually. So you can see how much compression you get because you have converted each pixel. Now you need to remember that it belongs to one of these 20 or one of these 10 cluster heads, and you just go and replace. So instead of every pixel, you just only need to remember that which cluster head it belongs to, and then just copy the cluster head. It will create this image for you. It will create this image for you. So this is what you do for. So this is, we have seen, let me just, yeah. So here is, this is the work of Dr. Fatima Khalik. She is now teaching in Bahria University. So there I was really interested because I could find the data, which is very hard to find, the public health data of Pakistan. So I thought, why not to just make use of that data. So we did was a framework for public health monitoring, analytics and research. And there we said, how can we collect data where we need to anonymize data? They got to say anonymous, and how you convert it into HL7 protocol, and studying the whole healthcare system of Pakistan, where there are primary level hospitals, then there are secondary level hospitals, then there are tertiary level hospital. So, and then there are lady health workers as well, and then there are some mental and children. Yeah, this is the healthcare system of Pakistan. There are primary care units, which are rural health centers, basic health units. Okay, there are dispensaries, and there are these child health centers. And then in secondary, you have Tehsil headquarter hospital, district headquarter hospitals. Okay, and then there are tertiary hospitals. Tertiary hospitals are all military healthcare, CMH, MH. These are tertiary hospitals, and then there are this district health system, and so, and then there are like eye clinic, dental clinics. These are another private. So the private takes care of 63.4%, and where public hospitals takes care of about 34% of the healthcare need of the country. And then there are NGOs, and they have free hospitals, and so they are only 1.7, like Shaukat Khanam and Shifa, this eye hospital. And so this is where we propose a framework where the data from every source through an HL7 protocols gets in here, and here you do the de-identification, because you don't want this public health record, so you don't want people to be identified, but still you want the area to be identified, that this is the area where this particular healthcare issue has happened. So we propose something like that. It came to this gateway, and then here we indexed it and then brought it to here, where we have these OLAP queues, and then we did, I'll show you what all we did in AI, machine learning, and to learn about this. So here is the many diseases require a socio-temporal, means you got to see their location, that where they are occurring, public health, from public health perspective, and you got to see at what time what is happening, because some of the diseases are time sensitive. For winter, there are winter specific diseases, there are summer, and there are dengue and other. So once you see a cluster, so clusters are in time and also in space. So that's the latitude and longitude. And once you go and you see these rings, and here are something which is all over the year, but something which is specific to a weather. So this is the clustering that we did. And this was interesting. We wanted to find out that if there are a cluster of diseases, even the same disease, where else you find the same disease spreading in the country, especially in Punjab. So finding the correlation or association of a hotspot, a disease which is spreading here, and it is spreading here as well. So these are actual data from the actual data. So you say, okay, so we created all of these, and where there were strong associations, we changed the width of the line, that these are the strong associations and these are weaker associations. So for some of the diseases at some of the locations, they were strongly correlated with the same disease spreading in some other part of the country at the same time. Okay, so we created this, and then we say what to do about it. Okay, so because we are a resource-starved setting, and we have only limited number of even vaccines, we have limited, even we have number of specialized doctors, number of medicines, everything is limited. So how can you basically, if you have a decision-aiding system where it's all data-driven, and you're figuring out the hotspots, and how can you move your resources to just do that? So this is where we said, let's have cluster heads. These are cluster heads of different type of diseases spreading at one time, and we were focusing on typhoid, influenza, dengue, cholera, ABS, scabies, gastroenterology, whatever, and malarias, and then we plotted all these as layers into this space, which is latitude, longitude, and every color means a disease. So we did this, and this is also like different diseases, cholera and their intensities are differently colored to find out what is being spread. And this is where we collected them. This is malaria and typhoid. How a malaria and typhoid are basically associated with each other. And this is scabies and typhoids and scabies and malaria, finding out their relationship with each other, and then associating with them that what area is closely associated to the other areas of the country as far as the similar diseases are spread there, and where are the hotspots, so to say. This is about dengue, that how the dengue is spreading in Punjab, in KPK, in Sindh, and at different time of the year, and how it's started taking. It's also Gaussian, that it starts and then it peaks and then it comes down, and it starts in this month, July, August. So it is August. So June is start from July, August, September, October. So this is a dangerous month, and October, November, December, and then it dies. And whereas in different regions it starts at different time, and also here in January and February it is. So we worked on this, and then this is where I was mentioning about the clustering. It was 2014. It was in Karachi, and here in Karachi, and then in 2015 it started spreading in other parts, and then in 16 in other parts, and then in 17. So we started like clustering these in different years and seeing how it is spreading, and then finding out its correlation with the other. This is with the temperature. So the correlation of these clusters with the temperature, that um, so this is the temperature. Apparently this is the temperature. So in what temperature it primarily has, you have more cases, 30 to 40. So it was coming around these other temperatures where we have more dengue cases, and this is where we have its correlation with the mega projects. So this is Peshawar, what was happening in Peshawar, and in the other part where the dengue was spreading. So these are the number of patients in that region. So clustering became very handy to do this type of analysis, especially one disease versus the others and the other external factors, and plotting them into this, finding out the hotspots. So I think it's a very valuable tool. So next time we shall learn about the Gaussian mixture model, which also shall lead us to the generative AI, because Gaussian mixture model are generative, because there you are actually from the data extracting a model. And so instead of data, now we are replacing a cluster head. There you replace it with a distribution. So you replace a set of points with a Gaussian distribution. So that's what the Gaussian mixture model is. So okay, thank you very much.